And now, oh, it was the one thing I forgot to check was my mic level, but it looks like it's okay. Okay. What are we doing? We just finished 15, so it's time to work on 16. Okay. How do we get set up? Mod 2016, 2016, 2016. Oh no, sorry, day 16. Change that to a 6, and then this, and then this. Create the file, jump to it. Oops. There we go. Put this in here. Put this in here. There's a bunch of setup work, isn't there? That has to be done. Okay. I think we're at the point where we can hit compile and it should, oh, that's Clippy. Here's run. Unsolved. Perfect. Yeah, so we don't even know what the problem is yet. Let's figure out what the problem is now that we have everything set up. Drag in checksum. You're done scanning this part of the network, but you've left traces of your presence. You need to overwrite some disks with random-looking data to cover your tracks, and update the local security system with new checksum for those disks. For the data to not be suspicious, it needs to have certain properties. Purely random data will be detected as tampering. To generate appropriate random data, you'll need to use a modified drag and curve. And we have a little link. Oh, there is something called a drag and curve. What does Wikipedia tell us? Oh, okay, yeah, it's a fractal. Got it. Start with an appropriate initial state, your puzzle input. Is that a file or a... No, it's just a string. I keep forgetting to set up the session key properly. I got to do that again. So let's copy this over. This is a puzzle input. And it looks like we'd be doing with string. Let's just save it as a string for now. Const puzzle input stir equals this. Right, and then we should get a warning that we're not using it. Okay. Then, so long as you don't have enough data yet to fill in the disk, repeat the following steps. Call the data you have at this point A. Make a copy of A, call it B. Reverse the order of the characters in B. In B, replace all instances of 0 with 1 and all 1s with 0. Resulting data is A, then a single 0, and then B. What? For example, after a single step of this process, 1 becomes 1, 0, 0. 0 becomes 1, 0, 1. 1, 1, 1 becomes something else. Okay, repeat these steps until you have enough data to fill the desired disk. Once the data has been generated, you also need to create a checksum of that data. Calculate the checksum only for the data that fits on the disk, even if you generated more data than that in the previous step. The checksum for some given data is created by considering each non-overlapping pair of characters in the input data. If the two characters match, 0, 0 or 1, 1, the next checksum character is 1. If the characters do not match, 1, 0, 1 or 1, 0, the next checksum character is a 0. So it's not XOR. Okay. This should produce a new string which is exactly half as long as the original, right? If the length of the checksum is even, repeat the process until you end up with the checksum with an odd length. For example, suppose we want to fill a disk of length 12. And when we finally generate a string of at least length 12, the first 12 characters are this. To generate a checksum, we do these steps here. This produces a checksum 1, 0, 0, which has an odd length, so we stop. This just is, it's a lot of string manipulation, right? So it should be straightforward to do. I'm not seeing any tricks here. Combining all the steps together, suppose you want to fill a disk of length 20 using an initial state of this value. Okay. And then so here's our test input, right? And then we get an answer. The correct checksum would be this. And so all we care about is the correct checksum. We don't care about all the rest of the data we're doing. So there's nothing to parse. I guess parse can determine whether or not we're doing our test data. Right, so we can just make this a string input string, and then just put that here. Like that, and then this goes, it gets a toString, and then we can just overwrite it in the parse function. Oh, looks like I have an extra space there. And then here parse will just say self input is equal to our test string, toString. That was it, right? Yeah, okay. And then we're going to ignore this puzzle input for now. So we'll do that. And then part one, oh, so we can do this, right? We can write a quick test, basic test. Oh yeah, so we're not really doing it this way, right? Okay. If I want to create like a separate struct which actually does the work, I think that's what I would rather do, right? Okay, struct. And what is this? We're just overwriting. We're overwriting data. We're at scramble. Let's call it scramble. And this has the input of a string. And then impl scramble fn new returns a self, which has a self. Oh, input string input. There we go. And now down here we can actually say let scramble, no, just scramble equals scramble new of the test input, and then assert eq, and we think it's going to be this value here. So we can just say this toString is equal to scram checksum. And this is all going to blow up. I'm going to take away the this thing here. Oh, I hate that. Alta-snips is just being a little too snippy. Okay. And then this doesn't get anything. And then this is just going to be let scram is equal to scramble new puzzle input toString, and then we're going to just output scram checksum, and that'll be the answer to that. We'll change this here and then see if this builds. It doesn't, because checksum doesn't exist. All right, let's make a checksum, and we can switch this over to test. Right, I want to change bacon toml test to change this to 2016. I mean day 16. There we go. All right, fn checksum. And for now, we'll just take in a self parameter, return a string, and then just return an empty string to get it to compile. This needs to be toString. Okay, and now perfect. Now our test is failing. Excellent. So now we have to follow all the steps here. So it looks like first we expand the string to a certain length, and then we do this checksum business until we have an odd length. So there's two steps to this, right? There's the fill step and the input. So we're going to just reverse the input, right? And then append everything together. First we reverse the input and then we flip all the bits. Okay. So we can say let reverse is equal to self input chars rev. That should reverse it. And then we should be able to map each character. Let's call it CH. Match CH. If it's a 0, replace it with 1. If it's a 1, replace it with a 0. And if it's anything else, we panic. Invalid input. And then we collect that into a string. Can we do that? It says string. And then for now, let's just return reverse so we can see that we reversed it correctly here in our test. So our input was 10000, and we have a 11110 output. Perfect. So now that we've reversed the string, we're going to create a new string. Oh, right. And we have to do this multiple times to expand it to the right length. So let's start off with a clone of let result is equal to self input clone. And then we can say while. We have to say how big the data is going to get. Right, suppose you want to fill a disk of length 20. Got it. Okay, so len usize. So now we have to make sure that all result len is less than usize. We have to do this step of reversing it. Then we can combine everything together. So result is equal to format bang, result, and then reverse, right? That's how we put it together? Yeah, so the beginning part and then the end part, right? 11 characters. Why is it 11? We're starting with 5. Oh, right. There's a 0. We put a 0 in the middle. Resulting date is A, then a single 0, then B. Okay, so let's do that. Glad I checked. Okay. And now result len is, oh, not usize. What am I doing? This should be len. So now the result is bigger than len, or it could be bigger than len. So we want to truncate it. Is there a string truncate? Rust string truncate. Trim. There's a trim. Returns a string slice with leading and trailing whites. Oh no, that's not it. There's no truncate. I just see these. Maybe in stir. Oh, wait. Oh, up here. Yeah. String has truncate right there. Okay, shortens this string to specified length. If new len is greater than the string's current length, it has no effect. Note this method has no effect on the allocated capacity of string. Okay, so then we can just say result. And what does it return? It doesn't return anything. So it's not. Okay, so it actually operates on the string itself. Truncate to len. And now we have to generate the checksum. Right? So this first part was doing this iteration to create enough data. And now we need to go through all these and grab pairs. Rust iterator. No. That's iterator example, iterator next, iterator trait. Maybe? I'm just looking for something in the iterator that allows us to grab, like, there's, oh, I thought there was like windows or something. There's a skip, peekable nth, turns the nth, next chunk, nightly only experimental API. Oh, that's interesting. It returns an array containing the next n values. Because that's what we want. We want 2 at a time, right? Is there like a chunk? I don't see a chunk here. That's non-nightly. I don't want to do a nightly thing. List iter chunk. Oh, it's in standard slice. You can get chunks. Array chunks, experimental. Regular chunks is not experimental. So we can just say chunks, but we need a slice to operate on the chunks. Okay. So we can say let slice is equal to result dot chars, and I think we can just collect it into a vec of char, and that we should be able to do chunk on the vec, right? Because vecs operate like slices. If I say let chunk iter equals slice chunks of 2, yeah, so that works. So we get back chunks of char. And then what we can do, we could say map into a pair, right? And this should be 2 chars, and then we can just say if they're equal, if the 2 chars match, the next Checksum character is 1. So we can say if pair of 0 equals pair of 1, then yield a 1, else yield a 0. And then we can collect that into a string. Yeah. And let's yield that and see if we get, after one round it becomes this. Oh. Right, after we calculate the checksum, after 1 round we have this. So let's see if we get this out, because I think this is 1 round of checksumming. Oh, right, I have to give it the length. First disk you have to fill is 272, it says right there. So let's do 272, and then down here, what's our test data? 20. So let's put it in 20. Oh, not there, here. There. That doesn't look right. Okay, so we did something wrong. Let's see if we got the let's see if we got this correct. Maybe that's where we failed. Let's try that first. Result truncate len, and then we can just say result, and then comment this out, and see if we have the correct 20 characters here. 1 followed by 5 zeros, 4 ones, 2 zeros. Aha. Okay, so we did something wrong with our let's print out each result as we come to it. Println result. And then we can compare it to these, because it shows each one of the steps. After one round, it becomes this. After 2 rounds, it becomes this. Okay, that's wrong. That's wrong. What did I do wrong? Oh, I'm still using self input. That's why. I should be using result. Okay. And now we can compare. Yes, that looks right. Okay. Good. Fix that bug. And then instead of printing these things out, instead of returning that, now let's return process. And this is processing 1 round. So we're going to compare this. And yes, that looks correct. It's 10 characters long, it's even, so we continue. Okay, so now we're just loop here. Result is this. We just say while result len mod 2 equals 0. While it's even, we'll do that, and then just return a result. And now the test passes. Okay, so that I think that means that we're ready to actually try the real data, which I just have to hit R for run over here, and it gives us this as our answer. So let's see if that's right. That's the right answer. Good. Okay, git status, git add source, git commit -m 2016 day 16 part 1. Okay. Let's find out what part 2 is. Part 2, the second disk you have to fill has the length of this. Again, using this initial state for your puzzle input was the correct checksum. Oh, okay. So nothing fancy. Let scramble new. I guess we could do this here. We'll call it scram, which is a scramble. And then self scram. Make it empty. And then here we can just say, in parse, we say self scram is equals scramble new. It's a little awkward because, but whatever. Puzzle input to string. And then this is just self scram checksum 272. And this becomes self scram checksum that number. It's a little bit bigger, so it's going a little slower. I didn't think it would go this slow, though. How big is this number? It's not that big, right? It's only 35 million. 14 seconds. Wow. And that's the right answer. I am running debug. So let me switch this over to running release, which does take longer to build, but runs faster. Oh, it should go here. Yeah, it takes a little longer to build. I'll live with that. But half a second versus 14 seconds. Okay. That's it. That's good. Oops. No write since last change. Okay. Git status. Git diff. So all we did was refactor this a little bit to move the scramble up into the object. And then we either pass in a 272 or 35 million. Okay. Git commit -am 2016 day 16 part 2. Neat.